Hello and welcome to week 5 for Statistics 1. This is a big week as far as conceptual understanding of some of the basics in statistics. So take your time with this week and in your reading. It's probably a chapter you want to read twice to really get a sense of what's going on. If you recall, in week 3, we spent time working on understanding different measures of central tendency. We took a look at the difference between the mean, the median, and the mode, and also what affects the mean, median, and mode if you have data, for example, that is either normally distributed or symmetrically distributed versus data that is skewed one direction or the other. If you have skewed data, then the mean ends up being pulled towards that tail wherever the outlier values are, and the median ends up being sometimes what we would call the more appropriate average for the data. But if you do have data that is symmetrical, where the mean and the median are about the same, then the mean also is definitely a very valuable average. In week 4, we took a look at measures of spread, measures of variation, specifically standard deviation. Standard deviation is a statistic that gives you a sense of how, on average, the spread of the values are, or the distance the values are away from the mean. And I hope you were able to take some time to view the one video. Hopefully it helped get you to understand the idea of standard deviation. In the Excel tools, I put in the one video titled Standard Deviation, I'll walk through the process. Now, although this was designed also to give you an understanding of how you can find standard deviation in Excel, hopefully the process that we walked through gave you a sense of what standard deviation is all about and how each individual data point is used to determine that standard deviation. Now we're going to turn the page and to what is called the normal distribution. And the normal distribution is going to show us how we can pull these things together. The mean, as far as a measure of central tendency, and the standard deviation, as far as a measure of spread. And again, take your time reading. I want to walk you through a couple screens or a couple pieces out of the text to help you get a better understanding of this rather than just reading it. So for example, on page 84, there's a histogram sketched in the one diagram where you can see the bars for each of these classes. And they're somewhat symmetrical. They're not leaning too much one way or the other. So this would be a set of data where your mean and your median are basically right around here at the 69 inches. And you notice they superimposed a bell-shaped curve, or what we call the normal curve, over top of this. There's quite a bit of phenomena in the world where data ends up being gathered or situated from a histogram in a bell-shaped way. It's normal. The word normal is used quite often to describe an occurrence in regular life. And the word normal really comes from statistics, where the set of data is spread out such. A couple of the key pieces of the normal curve. Again, it's a theoretical bell-shaped curve that is used as a model for normal phenomenon. It's also symmetrical. Use the understanding that this is a symmetrical graph to help you down the road. So that, for example, if 69 inches here is our mean and our median, you can understand that roughly 50% or half the population is above that average and about 50% below. And if you're at, for example, 71 inches away, or 71 inches, which is 2 inches away from the 69, you're about equally likely to be 71 inches as you are 67 inches. Also to understand with the normal curve is that the mean, median, and mode are all located about the same area right here in the middle. Later in the chapter, there's a chart that I think is very valuable. And this is back on page 101. And what it does is it shows you how, in one quick picture, how you can have data of normally distributed values. For example, GRE scores, IQ scores. In this case here, IQ scores have a score of, or a mean of 100 with a standard deviation of 15. So what this chart does is shows how every 15 points of an IQ score is another increment or another Z-score above, and then every 15 points below is another increment or another Z-score, or standard deviation going below. The GRE scores with a mean of 500 and a standard deviation of 100. So every 100 points or one standard deviation is another increment. These can all be superimposed in this format, or what we do use now is what is called the standard normal curve. And the standard normal curve is basically our ultimate template for normally distributed data, where the mean is set at 0 and the standard deviation is set at 1. So this chart will be used here to basically serve as a model for other information that we have throughout this course. Our textbook walks you through how to find what is called a Z-score. A Z-score is simply how many standard deviations a specific point is away from the mean. So for example, if I have a set of data that has a mean of 270 and a standard deviation of 15. If I have a score of 270 myself, I'm exactly 0 standard deviations away from the mean. I am right at the mean, so my Z-score will be 0. If I have a score of 285, which is 15 points above the mean, I am exactly 1 standard deviation above the mean, so my Z-score would be 1. Likewise, if I had a score of 255, furthermore, if I had a score of 240, for example, 240 is 30 points below the mean, or 2 standard deviations below the mean, or therefore then the Z-score would be a negative 2.0. Now, to continue on with this, and again, this is a brief overview. This is not to be an exhaustive explanation of this chapter. The chapter does walk you through how to find and make predictions of what proportion of the population is between certain values using the standard normal curve. And there is a table in the back of the book that we're going to use routinely throughout the rest of this course. And in this case here, Table A walks you through how to find the proportion or percentage of the population between certain values. And how this reads is such. This table, or this column, is your Z-score, or how many standard deviations you are above or below the mean. This column B indicates the area under the curve, or the proportion of the population that is between a certain Z-score and the mean. So for example, if I had a Z-score of 0.15 and I wanted to identify what proportion of the population is between my score and the mean, then I go down this column to 0.15 and I go over here to this column and I can see that it indicates 0.0596, which means 0.0596 is the proportion of the population, or you can move the decimal over to get 5.96% of the population is within 0.15 standard deviations from the mean.